Hello, our most valued student. My name is Confident. Welcome to part 2 of Engineering Science N2. And this is a revision of the question paper that was written in August 2021. As I mentioned, this is part 2. In part 1, we managed to look at the first 3 questions. And in part 2, we are also going to look at the next 3 questions, and we are going to end in part 3 with the last 3 questions. So you'll see that there are 9 questions in your engineering science N2 for the final exam. Now, just a recap. So we looked at this paper. It was supposed to be written on the 23rd of August. Actually, it was written on the 23rd of August. It was postponed, supposed to be written in July, but it ended up written in August because of some lockdowns. So this was your engineering science N2, and I've managed to go through the instructions and the important of your data or of your, it says use the following values. So these values are very, very important when you're doing your calculations, and you need to time it again, check and see that you make use of these values instead of using different values. And we looked at the first question. um, just if you have not gone through the first question, the second question, the third question, I'll encourage you to do so. And the reason might be either this is your first time to come in contact with this channel, the 24-minute lesson, or you might have missed it. Now, if it is your first time, I would encourage you to subscribe to our channel if you are watching this channel for the first time. Now, if you missed this channel, chances are you did not turn on that notification bell that notifies you every time we post some new videos. So just turn on the notification bell if you've already subscribed, because every time there's a new video, it shows you, and then you are able to choose to watch or not to watch. So if it's the first time seeing it, chances are you also did not turn on that notification bell. So guys, also share this channel to your friends and colleagues so that they can benefit from these revision sessions. And remember, sharing is caring. So the more you share, the more you practice with these, the better the chances of you guys passing, not just for the sake of passing, but passing with a mark that will keep, that will make you smile. There are some of those marks that makes you say, well, I just passed. But there are those marks, after getting the final mark, you're feeling good about yourself. You even take yourself out on a dinner. Those are the things that makes me want to do these papers, so that you can get the good marks and then be proud of yourself. All right, so as I said, we have managed to look at the first question, which is question number 1. So we've done that. We went on to look at question number 2 on the module of statics, and we went on, I think there is question number 3. We also went on to look at question number 3, which is on the module of energy and momentum. Now let us move on to look at question number 4. And in question number 4, the module that it is focusing on, it is the module on work, power, and efficiency. So that is what we're going to look at. So the first question is 4.1, and the question says we need to define energy. Now, there are different, actually, there is one common, very, very common definition of energy as being the ability to do work. So if you just use that one, you're good to go. Energy is the ability to do work. So if you just use this definition, that's it. It's an old common definition of energy, the ability to do work. You might say energy is the product of force and distance moved. So it's still correct to say it is the product of force and distance moved. In other words, you're showing us how to get or to calculate energy, and that is fine. But the simpler one is the ability to do work. You will get everything correct in that. So that is the first part, guys. You need to know the definition of that energy. And question 4.2, it says a crane hosts a load of 5,000 Newton. To hoist is to lift up. So to hoist meaning you're lifting up. So a crane, which is a lifting mechanism or a lifting object. So a crane hoists a load of 5,000 Newtons to the top of a building 30 meters high. So we have a building that is 30 meters high, and this crane must lift this load to the top of that building. The chain used to hoist the load has a weight of that. So maybe if I can just sketch this to you, let me have kind of a fresh page. This is just a sketch, remember, so it's not accurate. So picture a crane. So you have a building. I'm trying to have kind of so this is your building like that. So they say it is 30 meters. So this is the ground. So you have your building there. And then with the building, what you also have is, we are saying there is a crane, and picture this as the solid crane, whatever. And then this particular crane, it has to lift. Let me use a different one now. This particular crane has to lift a load from this point here. Picture a load here, and this particular load is there. So there is a load, it's very heavy. So this crane has to lift this load up, and then it says to the top of a building. So at the end of the day, you are having this crane like this. So this is the crane, and at that stage, the load is now on top of this building. So you see what is happening. So they are saying, so you are moving the crane. So this mainly is the chain. So we have a chain here in this crane. So that's what they're saying. So what they're saying is there is a crane hoist a load of 5,000 newtons. So you see that this particular load is 5,000 newtons. That's what they're telling us here, 5,000 newtons. And then to the top of a building 30 meters high. So if I look at this building, they are saying this particular building from here to that, it is 30 meters high. All right, this is just to show you like kind of an idea how this thing looks like. The chain used to hoist the load has a weight of that. Now the question says 4.2.1, that's what we're interested in, says calculate the total work done in hoisting the load and the chain. See now, two things, we have to hoist the load and we have to hoist the chain. Now the diagram that I've drawn is not the diagram that you need. Now you need to have a sketch of a graph of some sort. So this particular graph is, if I can draw my axis, so I can have my y-axis and I have got my x-axis. So just I want you to pay attention now. So these are my y-axis and this is my x-axis. So why now am I drawing the y-axis and the x-axis? It's because I want to find the area under the graph. So the y-axis represents my force in newtons, and this is the units, and the x-axis in this case represent the distance in meters. Now remember, we did mention that work done, we said it is force times distance. So the area under this graph is actually the work done. So now what we have, they are telling us that in this case, we have a crane hoist a load of 5,000 newtons to the top of a building. So now, how do you sketch that 5,000 newtons to the top of a building? So what you're going to have is, you're going to have, let's say this part somewhere here being 5,000. Remember, this is already newtons. So if you are saying you are hoisting a load is constant, is 5,000 newtons, you draw that by a horizontal line, and that particular horizontal line, they say for how many meters is 30 meters. So what you're going to have, you're going to go down here, and the distance that you're going to have here is going to be 30 meters. Already the units are in meters. So you see that? Now the area underneath this graph, the area is the work done in lifting this 5,000 weight of load. So that is the area now. So if I can come in here and say, what is the area? Remember how you find the area? The area is more like a rectangle. You're saying it's length times width. So you're multiplying 5,000 times 30. But let's call this our shape A. But we are not done. We also are told that this particular crane also has its own weight, and the particular weight of the crane is 20 newtons per meter. So for every meter, there is 20 newtons. For every meter, there is 20 newtons. So how do you express that? So they are saying for 1 meter, the weight of 1 meter is 20 newtons. But now they told us the building is 30 meters high. Remember that part? So what about 30 meters? What is the weight of the crane? So you multiply 20 times 30, and if you do that, you are going to get 600 newtons. So which means the weight of 30 meters is 600 newtons. Now we need to add this or to incorporate this in our force distance diagram. And for us to do that, remember already we are at 5,000. So now if we are to include the 600 newtons on top of the 5,000, remember this crane has its own weight and it has the weight of the load. So there is the 5,000 of the load, and then there is the 600 newtons of the crane. So in total is 5,600. So if I can include it somewhere here, just it's not to scale, don't worry. So this at that point becomes 5,600. So if I use that, I will have a line that comes down like this, and it's more like a triangle, and the area also underneath this triangle is the work done. So I'll call this shape B. So you can see that we've got two shapes, shape A and shape B. So now if we were to find the area as we did underneath each, so the first one is work done in a lifting object is the first part, which is equal to, that is A in this case, which is equal to, we are saying length times width, length times that width, which is the length is 30 times the width. In this case, we say it was 5,000. You see that? So when you multiply that, and then let me just take my calculator, it gives me 5,000 times 30. It gives me 150,000. Let me just be fast. 150,000 newton. I mean joules. Sorry about that. We are talking about work done. So W is equal to 150,000 joules. So that is the first part. Now we have to focus now on the second part. I'm going to work it on top here so that it's clear, so that you can see what I'm talking about. So in this top part, what I have is I have got this particular distance here from 5,000 to 5,600. If I can draw aside this shape, I'm having a shape like this. Just something not drawn to scale, but just to have an idea what I'm talking about. So I've got something like that. And then this distance here is 5,000 to 5,600. That distance is 600 newtons. And then the length, the base, you can see this is a triangle by the way. So the base is still the same. It is 30. So what do you find? How do you find the area here? Remember area, which is our work. We said work done is the area. So work done in this case of the chain, I'll call it work done on the chain, is equal to half times base times height. This is the area under. Remember, that's what we're talking about. Half base times height, which is 1/2, and the base is 30. And the height is 600. So when you do that, You can also find then that you have got half base times 30 times 600, and it gives us 9,000. But don't forget, it's 9,000. The work is in joules, so say C for the chain. But now you need to find the total work done, so I'll call it WT. So work done, WT, is equal to the 150,000 joules plus the 9,000 that we got on top, joules. And then if you add that, 150,000 plus 9,000 is 159,000 joules. If you want to convert it to kilojoules, you can divide by 1,000. So when you divide by 1,000, there's a comma there. It becomes 159 kilojoules. It's up to you. It's not a must for the last one, but the answer, you can leave it like that. It's better to always work with joules like that. So that is the first part. Let us look at the next question. So that was 4.2.1, and then 4.2.2 says we need now to calculate the total power required in hoisting the load and the chain if it takes 5 minutes to hoist the load. Now, also to remember, guys, I have formulas. Let me come and use the formulas. Now, the first formula where I was looking at work, it was this one, which says work is force times distance. That's what I was using. But now look at the power. For me to find the power, this is P is equal to W over T, meaning P is work done over time taken. So if I use that formula to say, in this case, let me use a different marker to say P is equal to W over T. We just got W, which is our WT, in this case the total work done, and therefore P is 159,000. Always use the joules one, divided by time. Let us go and look at the time. They're saying calculate the total power required to hoisting the load and chain if it takes 5 minutes. So you see the time there, but you must convert 5 minutes to seconds. So what you need to do, you need to come here to say how do you convert. Remember, I can just divide this like this, just to have kind of a conversion here. Now remember, to convert minutes to seconds, 5 minutes, 5 min is equal to 5 times 60 seconds. So 5 minutes is equal to 5 times 60. The SI unit of time is in seconds. So you see that we are dividing by 300. So it is equal to 300 in this case. So what we have here, we are saying 159 over 300, or you could have said 159 over 5 times 60. Then it is going to give you the power in this case, and for that you are going to say 159,000 over 300, and it is going to give us 530. So power is 530. Now how do you measure power? Power is measured in watts. Very important. Remember, I said write the formula, substitute in the formula, and write the final answer with the units or the proper units. So that is how you're supposed to answer that question. So let us move on. That was 4.2.2. So we've done question 4. Now let us look at question 4.3. Now question 4.3 says a 40 kilogram object is placed on an inclined plane forming an angle of 20 degrees with horizontal. So let us sketch that. So if I erase this, so they are saying what we have an inclined plane like that. This is an inclined plane, and then at the angle of the inclined plane here, they are saying is and a 40 kilogram object is placed on an inclined plane with an angle of 20 degrees with the horizontal. So in here, I've got 20 degrees. Are you seeing that? So that is the inclined part. Let me just make it clear there. So there is the 20 degrees. But this object, they're saying, I have an object here. This particular object here, they're saying it is 40 kg, right? 40 kilogram. All right, let me just write it maybe inside here to say this is 40 kg. It's good like that. I hope you can see that. So in this 40 kg object, there are a few things we need to do, but let's go back to the question before I go ahead of myself. It says a 40 kg object is placed on an inclined plane forming an angle of that. Now there is the question. This is 2 marks, so I don't think I need to do much here. It says just for 2 marks, calculate the required force to pull the object up the incline. So we need a force, and in this case, this is the force that I need. This particular force must pull this object up the incline. So if I need something that is going to pull this thing up the incline, we'll call it F. I'll say FA, meaning F applied, the applied force. So they're saying calculate the required force to pull the object up the incline. So now, how do I find it? As I'm saying, this question has, I think this question has got quite a lot of things that we're missing. It didn't tell us about friction. So we will assume, number 1, this is a smooth surface, because they didn't explain much. So if it's a smooth surface, number 2, ignore friction. Because when we put friction, there's going to be a lot of working, and for 2 marks, it's not going to be worth it. So let's assume there is no friction. We're just required to calculate the applied force to pull this thing up without the friction. But there is something that is always consistent with the object. It is the weight part. Remember, the object has got its weight facing down, and we call that the weight of the object. And you know what is weight from the formulas? W. There is it. W is for weight there, and W here is for work. So you need to know what you're dealing with. This one is for work. Work done is force times distance, but this is the weight, which is mass times gravity. So now here, if I use that weight, is m dot g. So mass times gravity, and they did give us the mass, which is 40 g, meaning 40 times g, which is 40 g. But you know that g is 9,81, so you need to put that value. So that is our weight. But now this weight has got 2 components. It has the parallel component and it has the perpendicular component. I'm going to use the red marker to draw those 2 components. There is this part of the weight. We call it the perpendicular component. So we call that weight perpendicular. And then we have also the weight parallel to the plane opposing the force applied. That weight, we call it weight parallel. So this is weight parallel. So these represent the weight in 2 components. Now the weight perpendicular here, we call it mg, m times g, cos theta. In this case, we know theta is 20. So if you simplify it, m was 40, g cos 20. But now the weight that is on parallel here, this is equal to, let me write going this direction, it's m g sine theta. My space does not allow me, let me write it down. So this weight here is equal to mg sine theta. You see that? But now we know m is 40g, and then its sine, and the angle theta there is angle 20 degrees. See that? So now, while you're doing it, I'm just taking my time, but this is what I want to show you so that you don't get confused. Of all the things that we're doing, ignore this part, ignore this part. What is important is this part because it's the one that is dealing with FA, and you can see that the only force opposing FA is mg sine, that is the parallel. So now if you simplify it, then you're going to say FA that is going up is equal to the force that is opposing it going down, which is equal to weight parallel. See that? There is no other force. As I said, we ignore friction, so there is no other force. So we say FA, which is what they want us to calculate. The question was calculate the required force to pull the object up the incline. So it is opposed by the component of weight parallel to the plane, which is 40 g sine 20. So that is how this thing was supposed to be. In simplified terms, it was going to be that. So you're going to say 40. So let me be clear also. 40 times g is 9,8 times sine 20. And if I simplify this part, then I'm going to have 40 times 9.8 times sine 20. And it is going to give me 134. Let me just do that again. Sorry, I lost that. I said 40 times 9.8 times sine 20, which is 134,07 newtons. So it's comma 07 newtons because we are dealing here with the force. So here you can say therefore required force is equal to, sorry, my writing guys sometimes is bad. Required force is 134,07 newtons. That's the force required to pull this kind of object in a way up the inclined plane. So that's what they mean when they talk of that. So that is to 2 decimal places in this case. Now let us move on to the next question in this case, which is question number 5. So we're done with question 4. It was 10 marks. It's a good 10 marks that you could have actually been able to take advantage and get all your full marks. Now let us look to question number 5. Now question number 5 is another new module, and the module here is in question number 5 is mechanical drives, as well as we are looking at lifting machines. Now let us look at question 5.1, and let me clear my space here so that we can get a fresh page. So let us look at this. It says a clock. So you're thinking of a clock. A clock watch has 2 gear drives with gear A driving gear B. I think you know the clock. At the back of that, there are drives that are causing the minute hand to move at a different speed compared to the hour hand, which moves at a different speed compared to the second hand. But usually, I mean, this one has got only 2 kind of hands in this case, the minute and the hour hand. Then it says the following is known. So now we've got NA, these are rotational frequency. The rotational frequency of gear A is 750 rotations per minute. And then T for teeth, the teeth for A is 25 teeth. The T for B is 50 teeth. Now it says calculate each of the following. 5.1.1 rotational frequency of gear B. So we are given the rotational frequency of gear A. Now if you go to your formulas, as I say, just rely on your formulas. Most of your answers, if you can just get a time to go through each and all of these formulas, you'll discover that there's quite a lot of information that you can use. So now this here, we're talking about the rotational frequency, and this is the formula there that we're looking for. See that? And it says NA times TA is equal to NB times TB. So if I use that formula to say NA dot TA is equal to NB dot TB. Now let's put the information that I'm given. I'm given NA is 750 and TA is 25. So I've got NA is 750 times TA is 25 is equal to NB, which is what I'm requiring, times what is TB, which is 50. So this is more of algebra. They want me to calculate NB. You can see NB is multiplying 50. The only thing I need to do then is to divide by. Remember, the opposite of multiplication is division. So what I have here, it will be 750 times 25 is equal to NB. Now I'm multiplying by 50. So to get rid of that 50, I must divide by that 50. Opposite of multiplication is division. But what you do on the left, you also do on the right. See that? So now I will have, in this case, after dividing, 750 times 25 over 50, it gives me 375. So I've got 375 is equal to NB. And if you therefore see that NB is equal to 375. Now go and look at the units of NA and match them. See, it's R per minute, which is rotation per minute. Don't forget, you need to substitute like we did here, and then your final answer needs to have the corresponding units or the appropriate units. So that is how many marks it gives you. It says 2 by 2, which means you get the first 2 marks. Now let us look at the other 2 marks. Now question 5.1.2 says the velocity ratio for the system. So we're looking for velocity ratio, which is called VR. Again, let's go to our formulas and look at the formula that connects the velocity ratio, and it's already tied in, and that is what we're looking for. VR there stands for velocity ratio. You can see it says NA over NZ, but in this case, since we're dealing with A and B, it will be NA over NB. So if I come here and say VR is equal to NA over NB, because that is what I'm having in this case. But I can actually show you from this formula here. You can actually I'll do that later just to show you. But now we know what is my NA. Remember, my NA in this case is 750 over my NB, we just calculated it is 375. That is my VR. So my velocity ratio will be equal to 750 in this case over 375, and then it gives me 2. So the velocity ratio is 2 over 1. So this is 2 is to 1. Remember, it's a ratio. You need to leave it in a ratio form. So it's 2 over 1. Then you say equal to 2 is to 1. Now I wanted to show you something based on this formula, which is my NA TA is equal to NB TB. Just look at this. If I want to have NA to have this formula, so what I'll do is I must divide by what I don't want. Remember, this is multiplication, so I must divide by TA. But at the same time, remember, I want to have NB here. So if I multiply here by NB, also on the left hand side, what I did, I must do also multiply by TA and NB. So it's TA times NB. You see what I just have? I've got NA times TA, NB times TB, then divide by TA times NB, TA times NB. So it's the same denominator, but look what I'm cancelling. When I cancel that, on the left hand side, I will have NA over NB, which is this formula, but look at what it is equal to. I will cancel NB, and NB becomes TB over TA. See that? So we used this formula. You can also use, because if this is our velocity ratio, so it also means our velocity ratio can be equal to TB over TA. That's another formula. Then you're going to say TB, they gave us 50 and TA is 25. So it is 50 over 25, and it's 2 over 1. So the ratio again is 2:1. You understand what I'm saying? So this is what I'm trying to drive it to say. You could have done it in two different forms, but the answer in this case was going to be the same. All right, so we are done with question 5.1. Let us move on. That was 4 marks, which is a good 4 marks. Let us move on to question 5.2. All right, so what is 5.2 saying? Question 5.2 says, name 2 types of hosting devices. So now when they are asking about a hosting device, remember to hoist is to lift up. I think I mentioned just to say the word hoisting means to lift up. So they're asking you, name 2 types of lifting devices. Already they've been giving us answers here. I don't know why in a way these guys didn't say that, but the first one is this one, a crane. It's a crane hoist. So that's a hosting device. The first one is a crane. You can choose that. It's a hoisting device. So that's why I say it's name 2 types of hoisting devices. And then you can also look at, remember, whenever you are lifting something, you can use pulley system. Is another one. Pulleys. A pulley is a hoisting device. And then sometimes you can use, like a roller door in a garage. So it uses a chain block. That chain block in a roller door, it's a lifting device. And then so pulleys, a chain block, and basically those are the ones. It's a crane, a chain block, a pulley system, but they wanted to, so you can leave it like that. So that is what they mean when they talk about any 2 types of a hoisting device. All right, now we're done with question 5.2. Let's go to 5.3. Question 5.3 says, a differential wheel and axle device has a velocity of 20. Now there is another one. It's just that it's a bit complicated, but this is a hoisting device. You see, they have given you actually answers, these guys. It's called a differential wheel and axle device. If you read your books, you discover that it's always under the part, this device is under the part of what do you call this, lifting mechanisms. From the topic lifting machines, it's under lifting machines and mechanical drive. So it's a differential wheel and axle device. So they are saying this device has a velocity ratio. Here it's your VR of 20, with D1 is equal to that and D2 is equal to that. Remember, the units are millimeters. We must convert them to meters. Millimeters convert to meters. With the mass on effort, there is the effort there of 60 kg. The mass of the load is 800 kg. So the mass of the effort 60, the mass of the load is 800 kg. This information is always important for you to always take note of whatever information they are giving you. So even here the 20, they are needed to underline. So every information is important, because with the information you are able to calculate some stuff. Because of this information, I'm going to work on it from here. Now 5.3.1, here says calculate the mechanical advantage of the machine. So mechanical advantage is termed MA. So let's go to our formulas in here. And in our formulas, we are looking for MA, which is the mechanical advantage. If you check our formulas, I think mechanical advantage, there it is. So guys, as I said, you just need to be familiar with your formulas. Look at this. Tells us about mechanical advantage. MA for mechanical advantage is L over E, meaning L for load, E for effort. So MA is L over E. Okay, I said I'll work from it here. So we have got MA, remember it's 5.3.1. So MA is L, which is load, over E, which is effort. Now, which is equal to, what is my load? Now, let's go to the information, what they've given us. Now, the load here, from the statement, they're saying a differential wheel and axle device has a velocity ratio of that, D is equal to R, D2 is that, with a mass on effort, there is the effort of that, the mass on the load, there is the load, is 800, but this is the mass, 800 grams, but the load, remember, is in newtons. So we are going to say 800 to multiply that by 9,8 to find the load in newtons. What about the effort? You do the same thing. They gave you the mass on effort, but we are going to say mass on effort is 60. You multiply by 9,8 so that it is in newtons. So if you now calculate the mechanical advantage, it's 800 times 9,8 over 60 times 9,8. And then you can still see that the 9,8 can always cancel out, but well, for the sake of this, just include it because the load is in newtons and the effort is in newtons. So it's 800 times 9,8, or it doesn't have an effect, over 60 times 9,8 in this calculation because it cancels out at the end. You can see that is 40 over 3. So the mechanical advantage over S is 13,333. To 3 decimal places, it will be 13,333. Now there are no units on the mechanical advantage. Remember, the load is in newtons, the effort is in newtons, they cancel out, it's just a ratio in some form. So that is 5.3.1. All right, now let us look at 5.3.2. They're saying effort distance for one rev of the drum. So if the drum is going to have a one rev or revolution, what is the effort distance? Now you need to go to your formulas again, where it connects the effort distance. Just going to show you this formula. This particular formula is the one that we're using now for the effort distance. So SE stands in this case for the effort distance, E for the effort, S for the distance, and then SL stands for the load distance, or the distance moved by the effort over the distance moved by the load. So you can see that V instead of DR, you can use your VR there. So VR is SE over SL. So I'm going to take that and say here VR velocity ratio is SE over SL. Remember, SE in this case we are saying is effort distance over, and then SL is load distance. Are you seeing that? Now in this case, how many marks this? This is 3 marks. They made it 3 marks because there are quite a few calculations then that you need to do. You need to go back. You will see. Okay, let me put this thing here. We have calculated this 13.333. Let me just put it here for now. MA is 13.333. Keep it there for now. Now we have, if we're talking about the VR, as I said, to say VR is SE over SL is equal to effort distance over load distance. Now in our statement, they did give us VR. They told us that it was 20. So here you are going to say 20 is equal to, now the question was the effort distance, you see. So 20 is equal to the effort distance over, and then we need to find out what is our load distance from the information that is given. How do we calculate our load distance? So now I'm going to do it here to say, to find this load distance is equal to, again, let's go back to our formulas so that you can appreciate again our formulas when we are dealing with the load distance. So now in here, just want to show you, so we have done the first part of the formula. Now whenever we are now going to be dealing in this case with the load distance, what we are going to do is you need to use this formula. Look at the formula that we're having here. You see, we have got this formula here that connects our VR and our D. It says dr is 2d d1 minus d2. Let me write that formula here to say 2d over d1 minus d2 is equal to, now I'll call it my velocity ratio as my VR. Right, I'm going to come back to the effort distance over load distance. Just want to show you something. Now this 2d in here, we want to find what is our d. Why am I using that formula? Because I will use then the formula which says here SE is equal to pi d. So keep that in mind. SE is equal to pi d, meaning effort distance is equal to pi. Remember, pi times diameter. This is from the formula of the circumference. So it's pi times diameter, the distance moved. But now I need to find my d, and then this formula helps me to find my PD. So I have d1, and they told me d1 is 300. So I'm going, and then I have also d2 is 240. So what I have is, I will have 2d over d1, in this case is 300, but remember we divide by 1000, so it's 300 over 1000 to convert it, minus, again, convert 240 to meters, is going to be 240 over 1000. Seeing that? Then this is equal to my VR. Don't forget my VR, and they told us my VR was 20. So for now, I can use that actually. And then if I use it, will be 2d over this will give me 0.3, and this will give me 0.24. So it will be 0.3, 0 minus 0.24 is equal to 20. If I separate that to say 0.3 minus 0.24, I'm getting, in this case, 0.06. So what I have here is 2d over 0.06 is equal to 20. Now, how do I make d the subject? So I need to get rid of that denominator. I multiply by 0.06 on the left, multiply by 0.06 on the right. When you do that, that's how you get rid of that fraction. So you will have 2d is equal to 20 times 0.06. Now I'm interested in remaining with d, remember? So 2 times d, the opposite of multiplication is division. You divide by 2 on both sides, divide by 2 on both sides. When you do that, you get the diameter of that wheel. So what is the diameter? Which is 20 times 0.06. Then you divide that by 2. It will give us, in this case, 0.6 meters. So this is the diameter that I'm having, which is 0.6 meters. But don't forget, I have this formula that I said I need to use to say effort distance, SE, is equal to pi d. Now I know my d, which is pi times 0.6, and then effort distance, I will say, therefore it is equal to shift pi times 0.6, and it is giving me 1,8849, which is 1,885. If I round off, 1,885 meters. So it's 1,885 meters. But if I want to convert it to millimeters again, because they gave me in millimeters, it will be 1,885 times 1,000. I think, which will be equal to, now if that is converted, which is 1,885 times 1,000, which is 1,885. 885 millimeters. Now, what am I looking at, guys? This is the effort distance, SE. The effort distance. So now, if I go back though, I was looking at this to say load, to find the load distance here. As you saw, sometimes you can use the formula here that I just gave in here to say, if you have got, let me go back to the previous formulas just to show you something. You see, I have in this case this formula that I said we'll be having to say 2d over d1 minus d2. You see this formula. So if I can go back here using this formula here, you can see that I can actually take, let me write it with a different pen just to show you, 2d over d1 minus d2 is equal to VR. So now you can multiply by d1 minus d2 here, and then also here by d1 minus d2, so that this cancels. Then you're going to have 2d is equal to velocity ratio times d1 minus d2. Then after that you divide by 2, you divide, I can even use this formula. Sometimes they will put it like this, over 2, so that to find this d, in this case the d here is equal to VR times d1 minus d2 over 2. But now don't forget, what you find, the effort distance, SE, is equal to pi d. Remember that? So now I have my d, which is this is my d. So now if I just say pi times, in this case you just multiply, if I do this, pi times VR times d1 minus d2 here over 2. Remember, this was multiplied by pi, and then this formula can further be, you can take this pi, rearrange it and put it there. It will be VR times pi d1 minus d2 over 2. You can use that formula straight like that. It could have given you the answer, VR. They told us the velocity ratio. In that previous one, it was 20. If you still remember these numbers, so you get 20 times pi, and d1 was 0,3 minus 0,24. I think it was d2 over 2. So if you can use that formula straight away, so what you have is, you've got 20 times, then you've got that, which is pi bracket 0,3 minus 0,24. You close that over 2. You use that, you get 1,885. Remember that, which is 1,885. In this case, it was meters. So that is the effort distance for that. So that is what you can use, guys, in this case. Now let us look at the next question. So that was our 5.3.2. Now we are looking at, just to erase here just so that you can see where we are. Now I'm looking at 5.3.3. So we are here now. Let me use this part. We are now looking at 5.3.3. Then it says the efficiency of the machine. If you can go to the formula sheet, and in the formula sheet, as we said, if you look again, everything is given in your formulas. If I can just erase this part again. Remember, we're talking about the efficiency, and this is the formula that you're going to use for the efficiency, where N, for that N efficiency, is MA over dr. Remember, the dr, we use our VR as our velocity ratio instead of dr. So N is MA over VR times 100%. So if I'm going to use that, remember, it's the kind of the N here, just like this part to say, it's not really an N, but like that is equal to, so how to say, it's MA for the mechanical advantage over the velocity ratio. You multiply that by 100%. The efficiency. Now, if you look in the first part where we did calculate the MA, the question was mechanical advantage. We got it was 13.333. So that's what we're going to use here. So that N is 13.333 over the velocity ratio. Already they've given us that it is 20. You still remember the question says the velocity ratio of 20. So I'm going to use that 20 here. Multiply that by 100%, and then it will give you the efficiency. And if I do that, it will be 13.333 over 20, and then you multiply that by 100 as a percentage, it gives you 66.665%. That's how efficient this machine is. It's 66.665, and it's in percentage form. So this is how you would have answered question number 5. So it's 5.3.1, 5.3.2, and 3.3. This was 2 marks. All right. So let us move on to the next question, which is actually, it continues to 5.4. So there is another question, 5.4, that is still continuing. And this was out of 17 marks, so there was quite a lot of marks on this question. Now, looking at 5.4.1, let's read 5.4 at first. It says the tension ratio. So that's what you're looking at, the tension ratio. Now, the moment they took off the tension ratio, remember T1 and T2. So the tension ratio of a tight side force to the slack side of a belt is 5:1. So you've got a belt here and you have a belt. So this belt, you have a slack side and you have a tight side. So this is the tight and this is the slack. So something like that. So you have that. So they are saying, so this tight side must be actually very tight, like tight, not slack. But you understand what I'm saying? So the tight side and the slack side, there is a ratio of 5:1. So which means the tight side to the slack. So tight versus slack. So the tight is 5, the slack is 1. So for every 5, this is force. Remember, this is 5 times the other. And the force on the slack side is 500 newtons. See, they're now giving you the force on that tension on the slack side. The driving pulley has a diameter of 300 millimeters, and its rotational frequency is, that is n there, is 50 rotation per second. Now look at this question. The question says calculate each of the following: the speed of the belt. Now if you want us to find the speed of the belt, remember, if you go to the formulas, everything, you must always check your formulas. Now looking at the speed of the belt, this is the formula that you're going to use. V is pi dn. So that is the formula that you have to use there. So if you write it down to say my V is equal to pi times the diameter, or the small d, times the n in this case, which is your rotational frequency. So that's why it's 2 marks, which is pi times, what is the diameter? They're saying the driving pulley has a diameter of 300. So you convert that 300, so it will be 300 divided by 1000. Remember, you have to convert it, which is 0.3 in a way, times n, which is rotational frequency, which is 50. I think that. So this can be pi times 300 over 1000, it's 0.3 times 50, and then it can give you now the speed of the belt in rotation, in meters per second, which is pi times 0.3 times 50, which is equal to 47,1238, which is 47,124. 47,124. Velocity is measured in meters per second. Guys, units are very important. You always have to include your units. Don't forget the units because they are very, very important. All right. So next one is, so that was the part. The next part that they want here is the power transmitted. So that's now 5.2, the power transmitted. Now you need to know how to calculate power. Now to calculate power, already we have got velocity. So let's go and look at the formula that mixes power and velocity, and you can see this is the formula. Effective force times velocity. F is the effective force, so P is F times V. So I'm going to use that formula to say P is equal to F times V. Now we already have our V, but we need to find our force. So now I'm just going to take this V aside. Let me write it down. They say V is equal to 47,124 meters per second. So I've got my V already there. I just want to do a few things here for the calculations of F. Now look at this. How do I find my F? That's what I'm looking for, the effective force. Now if I go to my formula, so everything always tied with your formula. Look at my Fe. See this? Fe is T1 minus T2. So if I take that formula to say F is equal to T1 minus T2 in this case. Now the T1 is the T1, which is bigger than T2, meaning T1 is the tight side and T2 is the slack side. But now they gave me a ratio. They say the tension ratio to the tension ratio of the tight side to the slack side. So I will say like this: tight is to slack. Just want to show you how you can work on this. So let's call it T1 is to T2, tight for T1, slack for T2. They said the ratio was 5 is to 1. Do you see how I'm going? And then they're saying the force on the slack side. There is the force. What is the force on the slack side? It's 500. So under here we have 500. So what will be the force on the tight side? So this is X. So if the ratio is 5 is to 1, it means if this is 500, the X part there is 5 times 500 is equal to this the tight side, because for every 5 newtons is 1 newton. What about 500 newtons on the slack side? It will be 5 times 500 on the other side. So you can see that the tight side, which is T1, is equal to 5 times 5,000. So it will give me 5 times 5,000. 500, sorry. It will give me 2,500. So that is what I'm supposed to have for FE is 2,500 minus T2, in this case, which is 500. You see that? So if you separate there, you are going to get 2,000 newtons. That's my FE. So in here, I have got P is equal to FE, which is 2,000 times the velocity, which is 47,124. And then if you do that, you are going to get if you just use the calculator there, to say 22,000 times 47,124, which is equal to, and then you can see that it gives you 94,248. See that? 94,248, but power is measured in watts, but you can divide this by 1,000 if you want to change it to kilowatts. So it will be 94,248 divided by 1,000. If you want to convert it, it will be 94,248, which is 94,248. This is when you work with kilowatts. So that is that, guys. So it was quite an important section. I will also time and again bring the part of the part on the section of mechanical drives and lifting machines, so that we can look at this topic in detail, and I will post it again. Just follow up on these videos so that you can get used to this. So this is out of 17 marks. It's one of the sections with quite a lot of marks, but keep watching and you'll be able to get more of that. Now let us move on to question 6. Now question 6 is on friction, and if we can look at, just have a blank page there. So let's look at the question. It says a trailer with a mass of 75 kg. So it's a trailer with a mass of 75 kg is pulled. So it is a pulling, which is applied force. Up is going up an inclined plane, which forms an angle of 40 degrees with the horizontal. So we need to sketch that. So what we have, we are having an inclined plane like that. It's pulled up. So what you have, you've got the angle. They are saying, we just looked at a similar question. They're saying it's pulled up at an angle of 40 degrees with the horizontal. The mass of the trailer is 75 kg. So if I can come here and say this is my trailer, it's 75 kg. Remember, we've just looked at something similar. Now, and then the question continues. They are saying it's pulled up. It's pulled up an inclined plane. So I need to show the pulling up, meaning there is a force that is going upwards in this direction. See that? We have a force that is F. It can be FA for force applied, but you can just call it F. Now, the moment I do this, then I must have the component of the weight and the weight part, and the weight is from the center going down. I have the weight of this trailer, which is my W. Don't forget though, my W is mass times G, which is gravity, but we know the mass, which is 75 times G. In this case, it is 75G. All right, this is just information that you just need to be having for your side. But let's continue. That is the part. And then they continue this question here and say the coefficient of friction. See, now they are indicating that there is friction in this particular slope. So if I come here to say expect friction here like that, so there is some friction here, and when you add friction, things get a bit complicated. Now that's why this is out of 10 marks. Now it says calculate the following: the weight component parallel to the plane, 6.1.1, 6.1.2, the minimum force required to pull the trailer up the incline. I need to know this question so that I know what I'm looking for. All right, so the first part, I need to show you all the forces that are acting on this, because this question like this, it needs you to show all the forces. Now I'm going to draw the component of weight, which is parallel to the plane. So the component of this weight, W. So here, there is the first component. It is parallel to the plane. So we call that our weight parallel, which is equal to mg sine theta. Don't forget. Then we have another one. Our weight component perpendicular to the plane, and it is called weight perpendicular is equal to mg cos theta. They don't change, they're always like that. You just need to know your m, you just need to know your g, and you just need to know your theta. Our m in this case is 75 g sine, our theta is 40. See that? In this case, our m is 75 g cos, our theta is 40. That's always like that. And then we haven't included this force, but now we are going to include this force, the component of the normal. Now the normal in this case, it is perpendicular to the plane, but it is opposing the component of weight perpendicular like that. You can see, so we have that and that. We call this our Fn, our normal force, or our N, which is the normal. Doesn't matter what you refer to. Or if you go to your formulas, they refer it. Let me just erase here. This is if you look here, NR, they refer it as NR. So if I go back here and actually write what they refer to it as, it is called NR, normal reaction. So if I just do this and say this is actually called here NR, just to maintain, this is the normal reaction. So this is what we have. But is this done? No, because I say there is friction, there is the component of friction. So if this thing is supposed to go up, friction will oppose motion. So friction goes down when F is going up. Don't forget that. So which means we must include friction here. So where is friction acting? Friction is acting opposing the motion. So there is our friction like that. So this is my friction here. So if you go to your formulas again, they use F mu for friction. So that's what you use there to say this is friction, which is F mu. That's your friction. Sometimes you just use the word F. It's up to you. So these are all the forces that are acting on this. Now let us go to question one by one. 6.1.1 says the weight, calculate the following. It's 2 marks, so it's not much. What is important is the 6. The weight component parallel to the plane. The weight component. Remember, the weight has got 2 components, perpendicular and parallel. So the weight component parallel to the plane, it is this one that we took here. See, I said weight parallel. So here, I write it down to say weight parallel, and this question is 6.1.1. So it's 6.1.1. Weight parallel, we say it is 75 in this case. G sine 40. Just writing that, you get your 2 marks. And then of course simplifying that, which is 75 times 9,8 sine 40. Then it will give you 472,4488, which is 472,449. 472,449 newtons. So this is, in this case, the weight component when it comes to parallel to the plane. So that's what they mean when they say the component of weight parallel to the plane. Don't forget, you substitute the formula. I think it's very important for me to write the formula first, to say weight parallel is mg sine theta, because there is not my working is here. So that is what you do the first one. Now let us look at the next one, and the next one is 6.1.2, because this was 6.1.1. Then the minimum force, look at the question, the minimum force required to pull the trailer up the inclined plane. So we need to pull this trailer. So now in this case, what they want is we need to resolve these forces to say which forces are going up and which forces are going down. So you can see that F, if we take F going up there, we say F going up, that's the only force going up, is equal to all the forces that are opposing F. Those are pointing opposite to F. Now the forces that are pointing opposite to F is the friction, which is F mu, plus what is opposing is the weight parallel there. Those are the only forces directly opposing. There is no any other force that is opposing F. So if we can find these two, F mu and weight parallel, then we will know the minimum force required. We already know work parallel because we got it in 6.1, but what we don't know is F mu. But F mu, there is some stages you need to take to find F mu. Now let me take you stage by stage also. The first thing about F mu is this formula. You see this formula which says in here mu is F mu over NR. So if I can write that to say mu is F mu over NR. See, they're introducing another new part which is called NR. Again, we need to find NR, and NR is equal to, now look at NR, there is NR, the force that is directly opposite NR is the component of weight which we said was perpendicular. See this? They are opposite to each other. So NR and weight are opposite. So in other ways, NR is equal to weight perpendicular. Once you have these three formulas, then you're good to go. Always remember, when they ask this question, they need three formulas. This is formula number 1, this is formula number 2, and this is formula number 3. But how do you start from? You start from 3, you go to 2, you go from 2, you go to 1. That's how it works. So let's start with 3. So NR in here, we say NR is equal to weight perpendicular, but weight perpendicular is mg cos theta. Remember, we got it from there, which is equal to 75g cos 40. So we have our NR, which I'm going to put it there. So now that is my 1. Let me go now. That is my 3, not my 1. That's my 3. Remember, I'm working backwards. Now I'm going to 2. Now to go to 2, I will say mu is equal to F mu over NR. But now I know my mu. They gave me the mu somewhere. Okay, it's on the previous page actually. They told me that the coefficient of friction is 0.4. That is your mu. So in here, when I say 0.4 is equal to F mu over NR, but where there is NR, remember I have got 75 G cos 40. You can simplify it, but I chose not to simplify it so that I don't have to keep on writing these decimal numbers. Now I need to remove that this fraction. So I must multiply by 75 G cos 40 on the left hand side times 75 G cos 40 right and left, so that this fraction is gone and I'm left with F mu now. So that 75 times cos 40 times 0.4 is equal to F mu. As I said, if you wanted to find the answer here, you could have done it here and say, I know what is my NR. You could have just simply said 75 times 9.8 cos 40. You can do it, says 563,043. 563, 043. This is your NR. If you wanted to, you could have done that. Okay, so now the F mu here will become, use again the calculator, which is 75 G. I think there is a G there. That's why now if you make errors, I think so. In actual fact, you can, if you want to, you can use that simplified one, which is the 563. You can use that one already, but I'm going to use this 75 times 9.8, which is my G, times cos 40 times 0.4. It gives me 225,217. So this is 225,217 newtons. So you see how this thing progresses. Now, once I have gotten that, this 225, I go back to the beginning. Remember, I said for me to be able to calculate, I need this formula. So I'm going to write it again down here to say F is equal to, it was F mu going down as well as weight parallel. So it was F mu plus weight parallel. Now we have got this. That's what we're calculating all along. We know what is our weight parallel. Our weight parallel is the first one that we did, which is 472,449. But our F mu, that's what we did to be 225. So that's what the whole question is about. So it's 225, 217 plus the weight parallel, which is 472,449. 472,449. Then when I do that, it will give me now the final answer, which is 225, 217 plus 472,449. And then when I do that, it gives me now the answer of 697,666. 697, just to write it clear there, it's 697,666. Now remember, we are dealing with the force, and the force is measured in newtons. So this is the minimum. The question was calculate the minimum force required to pull a trailer up the inclined plane. Then you get 2 marks. And then the last question for today is 6.2. So we're done with this question. Then we're looking at question 6.2, which says in 6.2 we are supposed to calculate the absolute pressure at the bottom of a 5-meter deep dam full of water. This is 2 marks. So they're looking for absolute pressure, which is PABS for absolute. So now go to your formulas again. As I said, always rely on your formulas. You need to know your formulas, guys. I don't know how can I overemphasize. They are very important, especially in the last part of this section of your paper. The more you know your formulas, the more you'll be able to understand. Look at this PABS. There we go. That's the first one there. So if I take that formula to the question itself, to say PABS is equal to PATM plus PMAT, see, which is the atmospheric pressure for PA. So it's PATM plus pressure for the material. Now look at this. When I'm given this formula for the absolute pressure, we know from the beginning on these values, we have the atmospheric pressure, and the atmospheric pressure is given there, which is 101,3 kilopascals. So I can multiply by 1,000 to remove kilopascal, so that it becomes a pascal. So pressure then, atmospheric pressure, let me just do this, PATM is equal to 101,3 times 1,000 pascals. Are you seeing that? So I'm converting to pascals. And then that is the first part. Now I need PMAT. Now PMAT is equal to, again, go to your formula. For you to be able to calculate PMAT using the 5-meter deep, you go to your formulas, and that is the second formula to say P is density times gravity times H is PGH. So when you do that, you've got that P and GH for density. Now remember, we are talking about water, so go back at the beginning, and then you look for the density of water. So there is the density of water is 1,000 kilogram per cubic meter. So that is the density of water. So when you go here, so which is equal to 1,000, that is the P, times the G is 9,8, times the height, they said 5-meter deep, which is 5. So you see how this thing works out. So when you calculate that, it will be giving us 1,000 times 9.8 times 5. So it gives us 49,000. So 49,000. This is pascals. Remember, I'm dealing with pressure. So now when I add now, it will be 101. I can simplify also that one so that I just add. So I've got 101,3 times 1,000, which is 101,300 plus payment, which is 49,000, which is equal to, when you add these values together, which is 101,300 plus 49,000, which is equal to 150,300. So it's 150,300. So it's 150,300. Remember, I'm measuring in pascals. You can now convert it back to kilopascals. So what you do, you divide by 1,000, and when you divide 150,300 divided by 1,000, it's not a must, but I'm saying if you want to, it will be 150,3. So it's 150,3 from pascals, then it's kilopascals. This is not necessary. Your answer is fine as being absolute pressure is 150,300. It's sufficient like that. So you don't need in a way to change to kilopascals. You can work with pascals. It is as good as correct in that case. So this is how you could have answered now this question for the absolute pressure 6.2. And now lastly, we are supposed to finish in the next session. We do question 7 and we do question 8, which will talk about particle structure of matter, the chemistry side, and then we do question 9 on electricity. So I will encourage you to always stay tuned for the next uploading of the other video. So after watching this one, remember guys, again, before I forget, these are called 24-minute lessons. The videos are always longer than 24 minutes most of the time. But now whenever you're studying, don't sit for the whole video, which is maybe an hour, and try to finish everything at once. You're not going to understand most of the stuff. What you need to do, your brain can only absorb a maximum of 25 minutes. After that, it loses concentration. So you'll be tuning in and tuning out, and you don't want to waste your time. So what you do is, for every 24 minutes, concentrate, and then after 24 minutes, take a break. Come again for the next 24 minutes, concentrate, and then take a break. When you're taking a break, do something completely different. You can just go outside and just kick a ball up and down, run up and down, just joke around, do something totally different. If you have got your siblings, just play with your siblings for a few minutes. If you have got someone that you can be joking around with, just joke with someone. Just do something totally different. What you're doing is you are recalibrating your brain so that when you come back to your studying, it is fresh again, and your brain will consider you that you are now sitting again for a new session. It won't consider the fatigue of the previous session. Of course, you'll be a little bit tired. You will be even sometimes tired if the section is something difficult for you, but it is worth more value to your time than trying to sit there for hours only to discover that you understood. For every 1 hour, only 24 minutes were the most effective time of your study. So guys, that's an exam tip. I will bring more of these tips sometimes during the lesson so that you can see what makes you get value for your time. Remember, time is money, so you need to get value for your time. Guys, we've come to the end of our lesson. I hope this was of benefit to you. And if you've not subscribed, again, remember to subscribe to our channel, and you'll be able then to be notified every time we post some new videos. We have come to the end of our lesson. Thank you.